Hello. Designing in the context of uncertainty involves accurately processing the magnitude of the reward and the probability of obtaining it. However, in most cases, we don't have the information to infer this probability, which called ambiguity. Evidence shows that the parietal cortex correlates with the degree of ambiguity. We hypothesize that the parietal cortex causally computes ambiguous probability. So, to test it, 82 participants responded to an ambiguous decision-making task, where the participant had to choose between two rewarded options with different probability distribution. In the no-ambiguity context, the probability was known, and in the ambiguity context, the probability was masked, forcing the subject to estimate the ambiguous probability. The data were obtained in two experimental sessions. The first step was to analyze the brain activity under fMRI, and in the second step, we measured the brain activity under EEG and inhibited the parietal cortex with transcranial magnetic stimulation. The behavioral results show that the subject preferred to choose the option with higher probability, but the degree of ambiguity shifted this preference such that in very high ambiguity conditions, participants guided their responses by the reward. Several cognitive models were fitted, and the parameter as tau was identified that correlated with this behavioral shift. So, brain results show that during decision-making period, the areas typically related to the reward prediction were activated, and in ambiguity context, there was an important activation of the parietal cortex. During feedback, we obtained an activation in the ventral striatum when they won. On the contrary, when the prediction was inaccurate, we obtained an activation of the medial cingulate cortex and the increased activity in the intraparietal sulcus. Then, when he inhibited the parietal areas correlated with the activity processing during decision-making to evaluate the role. We specifically inhibit the posterior parietal cortex at the intraparietal sulcus before feedback. Behaviorally, we found that the TMS stimulation modified the subject preference and tau parameters relative to the control condition. And the results of the electroencephalogram recording showed that the impact of the brain stimulation of the parietal cortex involved a decrease of the signal in the frontal areas related to the error processing during ambiguity. In conclusion, our work provides evidence that the parietal cortex participates in the probability computation in ambiguous decision. Thank you for your attention, and for more information, please scan this code. Thank you.